Okay, good morning. So in 1979, Unix, when it was being developed, they added in a change root system. And that was the beginning of isolation, where they could segregate files for each process. In 2000, FreeBSD, which is the Berkeley software development, came up with jails. 2001, Linux came up with a vServer. 2004, Oracle comes up with containers. 2005, OpenVZ, which is Open Virtuoso, came up with a Linux kernel for virtualization, isolation, resource management, and checkpoints. In 2006, Process Containers came out by Google. 2008, Linux Containers was the complete implementation of a Linux container manager. 2011, Cloud Foundry started Warden. 2013, they came up with a Let Me Contain That For You, which was an open source version of Google's containers. And in 2013, Docker came out, and that started off with the future of what we're looking at as for container management. What containers can do for you is isolate and keep your operating system separate from the other operating system. And what our people today will do, our speakers are Freddy Kristiansen. If you don't know who Freddy is, he's a technical evangelist, works for Microsoft and the Microsoft Dynamics NAV group. He's a tech evangelist in the Copenhagen Center. He's deeply involved in the partner programs and tries to assist partners and ISVs to adopt the new technology. He's also responsible for all the nice Azure Gallery images for Dynamics NAV, and looks into how we can leverage Docker and Windows containers to make deployment easier for developers, partners, and customers. Next, we have Tobias. Tobias Fenster is with, oh geez, I didn't ask you how to say the name, Exians Infoma in Germany. He started as a developer in NAV 20 years ago, back in 2004, and he is the his responsibilities lead him to know a good number of internal development, testing, and QA and migration environments. And he works, currently he's working on making a true DevOps pipeline for NAV on TFS and a fully automated build system, creating the product package for over 1,000 customers. You'll find that he's the author of his NAV blog, .informa.de, where he writes a lot about NAV in connection with Docker and the Windows containers. And then last but not least, Jakub Janek. Jakub started his career in NAV in 2005 as a software developer in Navertica at the Czech Republic. Since 2003, he's been working for Olivia Systems, which is now Marquise Olivia in Spain, his last 3 years as a freelancer. He's been doing a lot of integrations with third-party softwares, and since September 2006, he's been investigating possibilities of Windows containers and relationships to Microsoft Dynamics NAV. He and Tobias were very enthusiastic about it, and they've created and maintained together a GitHub repository, which will probably show you. But if you look up github.com, KOUBEK, Docker files -dynamics -NAV, that'll give you the repository hub. And without any further ado, we're going to switch to Tobias.
Yeah, so thank you for that introduction, and welcome to the webinar about practical insights and examples for how to use NAV on Docker. I hope you've all seen in the invite in the description of that session that we expect you have seen the NAV Tech Days session about NAV on Docker, or the directions sessions about NAV on Docker, so you have some basic knowledge about how all that works, because today we're going to build on that knowledge and show you how you can put all that to practical use. We've already been introduced. Jakub and I will do the main presentation today. As we've been already introduced, I'll skip that one. Freddy will be here for questions and to let you know if Jakub and especially I am telling you something that's just wrong. Okay, what have you prepared as topics? The first is how to get up and running. So if you've seen all this, maybe directions or attack days, and you want to get up and running yourself, how does that work? Then the second topic that has come up a lot, and a lot of people were asking about it, is how to do the database handling. What options do you have about authorization, about storing the data, about persistence? And the last one is how can you customize what you have if for whatever reason you need to change the way that the standard Docker image for NAV is working. So to start it off, how do you get up and running? You can do this either on Windows Server 2016. That means you need to activate the container feature. On the right, you can see the dialog that you see if you want to turn Windows features off and on. And one of those is just containers, the fourth one here. You need to activate that. The machine will restart, and then that feature is there. If you want to do the same on Windows 10, it's slightly different. The main reason for that, and we're going to talk about that in a bit more detail, is how containers work on Windows 10, but you need the Hyper-V feature activated as well. For Windows Server 2016, that's not necessary, but on Windows 10, you need the Hyper-V feature as well. And the new Windows Server 1709 also needs the Hyper-V feature because the NAV images are still based on Windows Server 2016. And to make that work on a Windows Server 1709, you need the Hyper-V feature there as well. So those basically are your three options to run Windows containers and therefore NAV on Docker, Server 2016, Windows 10, and Server 1709 with those prerequisites. And with that, I'll turn it over to Jakub to let you know how you can install that. And he'll talk a bit about what we can see here.
Okay, so on Windows 10, we can use pre-installer provided by docker.com. You can go on the website and you can download and install one executable, and that's it. On Windows Server, you need to install Docker Enterprise Edition, and this should be installed using PowerShell modules. So there are several options. You can follow the description provided on the docker.com website, on the documentation website. So you can install using these two command lines: install module Docker provider force and install package for Docker. There is another option. You can follow the link, the second link. This is a gist on my GitHub repo, and this link follows you to a script, to a PowerShell script that will detect all required prerequisites and will install Docker Enterprise Edition on your Windows Server. If the Windows Server is not compatible, it will actually, for some reason, it should give you some feedback. It should also, if you have any version, any existing version, and you want, for example, to install some specific update, and you are waiting because the publishing of the packages go by waves, so you are probably waiting for some specific version, you can run this script. This script will show you what is the latest package available on the repo, and you can decide if you want to install or if you want to stop the installation process and if you want to remain with the current version. The last option about the installation is NAV Container Helper. It's a tool provided by Freddy Kristiansen. You can find more information on his blog. This tool actually is something like a wrapper between NAV containers and your host system. And you can use this NAV Container Helper to simplify a lot of usual tasks you can do with Docker for NAV. So, Tobias, you can continue.
Thank you. To add maybe on the NAV Container Helper, that really is a nice one if you start working with Docker. Jakub and I will be using a lot of the Docker basics to really show you what's going on, but also because we're used to doing it the Docker way. But really, if you're starting, then I would very much recommend you go for the NAV container helper, because it eases a lot of stuff, and you can understand quicker and more in NAV terminology what's happening, and less need to think about the Docker way. So also something that you need to understand or might help if you're running into whatever issue is that on Windows Server you get the Docker Enterprise Edition. That one is licensed with the Windows Server license, so that is actually a paid version, but if you buy Windows Server you get it as well. And what that does is it's using process isolation. As we heard in the beginning, there's some history to Docker, starting from change root to history around containers, I should say, starting from change root to the place where we are now. And what process isolation does, it works with almost no overhead. But you can also do something that's called Hyper-V isolation, which means that you're running a small virtual machine, and inside of that virtual machine, the container is running. From a resource perspective, that doesn't make too much sense. It's just more overhead than you need. But on Windows 10, you only get the Docker Community Edition, which is the free, the open source variation, which usually is a couple of versions up on the Enterprise Edition. But that one allows Hyper-V isolation only because you're going to run Windows Server Docker images. And the Windows Server kernel and the Windows 10 kernel are different, so you need that thin VM or Hyper-V VM around it to make it work. That then results in the fact that you will have to reserve memory for your containers. So the base idea of Docker on a Windows server, on containers on a Windows server, is that everyone can share all the resources. So you get more out of your resources, but on Windows 10, you have to reserve the memory. So that means you're going to start it and reserve 3 GB of memory. And even if the instance itself would only use 1 GB, then still all the 3 GB are gone. So that's something to keep in mind if you're running it on Windows 10. That works fine technically, but there are some issues around it in the sense that it's not working the same, and it's not working as efficiently as it's working on Windows Server. If you have the chance, if you don't need it locally on your laptop, I would very much recommend to use a Windows Server, because that's a lot more stable in my experience. Which doesn't mean that it's unstable on Windows 10, just the little things that come up with it that I haven't seen as much on Windows Server. How do you get your image? So if you want to get started, the first one after installing is your so-called pulling an image. What that means is that you're downloading that image to prepare to run it. And that works by specifying Docker pull, then Microsoft/Dynamics NAV, because you want to download Dynamics NAV from Microsoft. And then you're going to add a tag. And that tag consists of a version, a cumulative update, and the country version or language. So for the version, you can specify 16, 17, 18, and dev preview. And for the CUs, I mean, you get the ID there. And then you have a number of countries where if you omit it, then you get W1. For the CUs, if you omit them, you get the latest, and also for the version. So to give you some examples, if you do a Docker pull with a tag of 2017, then that means you get NAV 2017 with the latest CU and W1 localization. If you do a pull for 2016 CU18, that means you get NAV 2016, you get CU18 as you specified that, and you will get W1 because you didn't specify a localization. And the last one shows that if you do 2018 DK, then you're going to get the latest CU of 2018 because you didn't add a CU, and you would in that case get the Danish localization. You can obviously combine it as well. So if you do like 2018 CU1 DK, that would give you 2018 CU1 when it's there, and then the Danish localization. That's important to understand because you need to make sure that you're running the right version to then get what you expect or what you need. Starting your first container is as easy as you can see here. So if you're using the standard Docker command, you're going to do a Docker run, which starts that container. Then you need to accept the end user license agreement, which you do using the -e, which is called an environment parameter. You set it to yes, you accept end user license agreement, and then you tell it in that case you want to run Dynamics NAV 2018 in the RTM W1 version. You would do the same by using the nav container helper, by using the new nav container commandlet. You can give it a container name, and then you have the accept EULA as well, which just does the same. And then about the Hyper-V isolation, as I said, you need to reserve some memory for that. So you would add a parameter -m for memory, and then 3G for 3 GB of memory. And that one would, as I said, be reserved no matter if the instance actually uses less. Okay, with that, I'd like to hand over to Jakub, who will show us a quick demo of how you can start your first container.
Okay, so I hope you can see my screen. No?
I think not yet.
Not yet. So just a second. We will switch to my screen. Okay.
Yeah.
I hope right now. Okay, so as Tobias has told, we will run the very simple example, the basic one, which is actually running this command. I will start the command right now, and I will describe it a little bit more. The container will be starting about less than 1 minute, I suppose. So we have some time to describe the parameters. Actually, we have just one parameter here. This is the advantage of this command. We can write 2 or 3 lines of the code, and we will have NAV running in a container. We can access the container. We can access via using web client. And we have more options. So you can see we are saying Docker run to start to create new container and to start it. Later we will show that it's possible to stop containers and to run to start them again. So this is another option. But to create a container, we need to run Docker run. And then this is mandatory parameter. We need to accept end user license agreement. If we don't accept end user license agreement, we will receive an error saying that we need to do so. And the last line, you can see we are pointing to some specific Docker repository, which is a Microsoft repository with Dynamics NAV. And as we have been talking about tagging, we are using the version 2018 RTM. If we do not specify any language, we could specify, for example, as like Spain version. So if we do not specify anything, so we are running actually W1. And you can see the output. The container should be running right now. And in the output, you can see we have a user. We have user admin. We have user password. Because we do not specify any specific user, container will generate one user for us, and we can see we can access web client using this URL. So I will copy this URL and I will access this container. I suppose I will receive this error exactly because we are using HTTPS scheme. So with self-signed certificate, so we should be, we need to install the certificate. If we want to do so, we have this file here also generated for us. We can download it, accept the certificate, and use it later. Copy the password. And right now, I should be able to access the container to NAV running inside the container. Just a few seconds. You can see there are more information generated for us. We can see host name of the container. We can specify our custom host name. We can assign a specific name to the container. In this case, it's generated for us as well. And you can see also V6 file for AL development available here because we are using 2018. And now we are inside, we have accessed NAV inside the container. So it's pretty easy, I think, to start working with NAV with Docker. So that's all from me right now. And I will switch to Tobias.
Okay, thank you. So you should now hopefully be able to see my screen again. So that was the demo about starting the first container. Now I'll give you a brief introduction on how layering in Docker containers works, which is important because we're now going to talk about how to handle the database that you're going to use in your container and connect it to your NAV server instance. Layering works so that the image that we've just seen is also created by using layers. So the base layer is the Windows Server, then you add SQL Server, you add NAV, you maybe add IIS, and so on. And then on top of all those is one container layer. So if you're creating a container from an image, then you get one additional layer that's open for reading and writing. The others, the image layers, are just for reading. That means that anything you do as a write operation happens in that top layer, in the container layer. So if you modify an existing file, then Docker checks if that exists in that very top container layer. If it's there, then it modifies it. And if it's not, but it should exist in the image, then it needs to drill through all the layers from the top down until it reaches the version of the file. And then copies it to the top layer and starts modifying it. So that means that if you're doing write transactions inside of a container and you do nothing else, then you're hitting some performance bump there, because of the way the layering works. As I hope you've seen the presentations that we had, that layering works a lot in your advantage in other scenarios, but in that case, it gives you a bit of a performance hit. And to work around that, there's a way that's called volumes. And the volume means that you map a host folder to a folder inside of the container. So you have a folder on the machine that's running your NAV containers, and you map it to something inside of the container. And that means that the whole layering doesn't apply, but instead you just get the same performance that you would have if you would just access that folder on your host machine. So there's no performance overhead on that. To give you an idea, again, this is talking about a Linux image, but it's exactly the same on Windows. You have the read-only layers for the image, and then for each of the blue containers on top, you get one read-write layer, which just has all the changes that happen inside of your container. So what do you need to consider if you're thinking about running an NAV container and where to put your database? If you have a database which is coupled exclusively to that one NAV server instance that's going to run inside of your container, and also if you can easily recreate it, for example, in a demo or in a sales environment, and you don't rely too much on the performance, then you might put your DB inside a container without a volume. That will mean that you hit that performance overhead, but you don't need to do anything else. If you want better performance, and the database also needs to survive a recreation of the container, for example, if you're upgrading your environment to a new CU, then you need to go for another scenario, which means that you still could have the database inside of the same container, but you would use a volume, because one of the other issues with not using a volume is if you remove that container, if you delete it, then all the data that was changed inside that container also is gone. If you use a volume, then that's not happening. You have persistent data inside of a volume. And a third scenario that we'll be talking about is if you have multiple NAV server instances and you need to fully tweak performance and just be as flexible as can be, then there's scenario 3 where you have your database in a central SQL server as you would use it without a Docker container at all. Some detail about those scenarios. If you do it inside of a container without a volume, as I said, then that one is stored inside of the container layer. If you remove the container, then the data is removed also. That doesn't happen on restart, but if the container is removed. And yeah, the performance is lower as I described. Why would you still do that? It's very easy to spin it up. As you've seen, what Jakub just did, that one is exactly doing that would have the database inside of the container. So that's ideal for demos or simple testing, or workshop or training where you just want to put up a number of pre-configured environments, use them, and then after a while you're done and you just throw them away. The performance is not ideal. Then you also are bound to the SQL version that's inside of the NAV image, which is a SQL Express. Means that you can, sorry, that you can't have more than 10 gigabytes of database size. And also because you're connected to that one NAV server instance, that will mean that you have one SQL instance with the overhead that a SQL instance brings for every container. In our second scenario, we have the database still in the container, but we're using a volume on that one. Sorry, my voice is going a bit away. That means that the data is mapped between the container and the host, and it will never be removed. And you should have the performance that is practically the same as if you're running on the host itself. It is quite easy to spin up that container, and it performs better. So the use cases are almost identical. You get a bit more performance, and you get persistent data if you remove the container. So it's not gone if you remove it. But still, you're bound to SQL Express, which means 10 gigabytes of memory. And you still will have a SQL Server instance per container, which might be a big overhead if you have multiple containers on that one. And with that, Jakub will show us how you can use a volume for the database.
Okay. So right now, I will show you how to run one NAV container with SQL container and with SQL service inside the container, but on the volume. This means this is the second scenario described by Tobias, and the advantage of this scenario is the performance, because your database is lying away of the container file system. It's practically, it will be the database will be deployed on your host system, file system. So I will start the database on the container. Oops, sorry. I have a per one here. It's not recognized. Ah, sorry. Okay. I have done some changes. You can see right now I'm using a bit modified version of the standard containers. I'm using sorry, I think I have removed some files here. Just a second. Okay, end user license agreement. I think I have done some changes accidentally.
I think you're missing the backtick in line 19.
Again, this is the problem. And the container already exists, so I need to remove it. Okay. So in this case, I'm using some extensions of the standard functionality provided by Microsoft. You can see I have some own proprietary script here. I'm practically changing the way how the database will be restored, because in the standard containers, the database is deployed inside the container. It's deployed inside the container file system. So I want to change the behavior, and I want to deploy the database backup on my host file system. So you can see I'm mapping in this folder inside the container, or I'm using this folder inside the container to restore the backup. And as you can see here, the same folder is being mapped. I haven't done it. Sorry, I haven't mapped this folder here. Sorry for that. Actually, it should be like this. It looks like I have removed some multiple lines from the script, so I need to repeat the Docker run. At least you can see that the container is pretty fast to start up and to deploy the database. So I will repeat the run. And I will repeat all the steps. I will create again the container, and I will deploy the container into my file system, hopefully. As I've been talking, I'm using some additions. So I'm modifying these two files to say to the container to skip the standard behavior and to deploy my containers on the file system. This is the principal line where you can say, okay, I want to use this folder inside the container. And this is actually the change I have done here. It should deploy my container into my host file, which is in the same folder. No. I think I have some problem here. If we can continue, I will check the script. We can continue if you want, Tobias, and we can repeat this step at the end. But actually, the idea of this script is that the database should be restored here in this folder on my host system. So if I kill the container, the data should remain existing in my host system, so I can take the database and I can continue later with the same database, and I can continue with all changes that have been done inside the database. So I will check my script, and we can repeat this demo at the end if we have some time. Okay?
Okay. So what you've seen is that -v parameter that Jakub was talking about, that's the one that's doing the volume. So V stands for volume. The third option would then be to store the database outside of the container, which very likely will result in the best performance because you can tune your database server as you need it, and it definitely provides you with the most flexibility because you can then run SQL as a traditional service as you're doing today, either directly on the Docker host but outside of the containers, or on a remote system on a central SQL server. And you can also run it inside a container, as a SQL Server is available as a container as well, on the same machine or on another machine. And then you can obviously choose the additions, Express, Developer Standard, or Enterprise, which means that you're no longer bound to the 10 gigabyte limitation. So the big pros on that is that you can do whatever you want. You don't have any limitation by NAV on Docker. It's just the database considerations are the same as you would have if you're running NAV outside of a Docker container. It's just absolutely the same. If you want to have performance optimization, then that's the way to go because you have everything you need. And you have a minimal overhead because then you would have just one SQL instance for all the containers, or if you need multiple SQL servers, then you would have multiple SQL servers for all the containers, but definitely you won't have one SQL instance per container as we had before. Yeah, and the con on that is that it's harder to configure. That got a lot easier with the latest changes that Freddy made in the image, but it still is a bit more of an overhead. For authorization, what do you need to consider there? We need to authorize some way to the database server. That is not an issue if you're running the SQL server inside of the container. Then it just works. As you've seen, you get a password that's generated for you, and that's the same for the SA user. use the SQL Server outside of the NAV container, then you need to consider what you're going to do there. You can either use SQL authentication by adding just parameters to the Docker run or using the NAV container helper, or you can use Windows authentication. That means that you need to do something that's called a group managed service account, which needs to be set up in your Active Directory and is a bit more of an advanced topic there because you need help from the AD admins and they need to set up users. But we'll later see how Jakub has also automated that one as well. And then for Seaside, it's the same. Yeah.
We have a question here in
sure.
This. How can we find out what folders are used inside the container? Is it only from the documentation? And if there's a script, what scripts are executed?
Okay. To find out what's actually happening inside, you can either look at the documentation, but also probably the easiest is to just start up the container, go through a PowerShell session inside the container. That the NAV container helper has something that's called Open NAV container or Enter NAV container, sorry. And with that, you get a PowerShell session inside the container, and you can just look at it and see which folders are there.
Okay, thank you.
And for the scripts that Jakub showed, a lot of that is on his GitHub repository as well. I'll be showing the link in the end as well, so you can just check there. And then, yeah, that's how you authorize to the SQL server, but then we also need authorization for the NAV server connecting through the Windows or the web client or through VS Code. Start it and let it do its thing. Then, as we've seen, it will create an admin user with a generated password, and we're doing NAV user password authentication. And you can also give it a specific username and password, but tell it to not use Windows authentication, and that will mean that it creates that user, gives it a password, and allows you to connect through entering that username and password. And if you give it a Windows user and password and configure Windows authentication, then your Windows SSO will work. That's kind of a trick, because if you're using a Windows user that's exactly the same as your Windows user on the host, and you're using the exactly same password, and you connect through the Windows client, the web client, or VS Code, then it will just compare the username and the password, and if it's the same inside the container, then you get single sign-on and everything works automatically. And then there's the most advanced topic or advanced setup with using the group managed service accounts, which will just make all the Windows logins inside of the database work. I hand it over to Jakub to show you group managed service accounts.
Okay, thank you, Tobias. So just before starting with GMSA, I would like to show you that the previous example is working right now. I was missing this environment variable, which actually says what is the backup to restore. In this case, if I omit this parameter, container will use the standard database, which is already deployed on inside the container. So in my case, in my previous case, the container was starting with the standard database, so there was no backup restore actually running. In this case, you can see I have my database deployed here on my host system. So if I kill the container, if I remove it, the database should remain persistent on my Docker host system. You can see the database is still here. So now I would like to switch from the Azure demo to our environment in Marques Olivia. In Olivia, we are using GMSA to substitute the original installation we were doing with all NAV versions. We have customers running on different versions, so we had many problems to run multiple NAV versions, or especially one version with multiple cumulative updates. So when we switched to containers, and this was actually a point for us to use containers to avoid these problems, We are using one specific Docker host system, which is a Windows Server 2016, and we are running all containers on this Docker host machine. So we are running, for example, multiple 2016 versions, 2017 versions. We also run some 2009 versions with our custom implementation. For example, we have one customer running also running on native database server, which is running inside the container. So we were doing some migration. We were using Docker to run database, old database NAV server inside the container as well. So this is another host. I'm using this host only for demo purposes. So you can see I have one script here, one Docker run command, which actually starts the container inside the domain. This container, which will be created here, I have actually run the container. You can see the container is active right now, has been joined into the domain. How it's being done? So there is something called credential specification file. You can enable this file using this line. You can see we are using some parameters here. We are doing the configuration on the upper part. You can see we are specifying which image, which Docker image, which NAV version we want to use, what will be the IP we want to use, because we are using something called transparent networking. This allows us connect the new containers into our LAN network. So the containers practically behave like the standard machines, so like standard computers. They have their own networking stack, and we can access them. We also register those containers inside the DNS server with this command. We are using some specific modules, PowerShell modules, to help us create the containers and to connect every necessary aspect into the domain. So the IP and the container name is one of those aspects. The second command we are using is this one, which actually create for us this credential specific file. If we go to the file system of the Docker host, you can see we have a folder inside program data Docker credential specific file. You can see we have a file with the same name we assigned the container. So this file actually helps us to connect the container to the domain. All those names or host names are being registered also in the domain controller. This is done using this command, this PowerShell command. And I repeat, this is our custom command we have developed for us. This command actually create all GMSA accounts inside a specific security group. So later we can access to SQL Server, and we can assign the security or login to this this group. We are using this group called Docker GMSA group, and you can see I can go directly here. This is this security group has public access to my SQL I will be using here in this example, and I need to specify user mapping. So I am saying, okay, this security group has access to NAV RTM-AS Docker demo, and you can see I'm saying the same I'm using this database. I'm configuring this database here in Docker run command. So when I start this container, every information described here will join and will create all necessary data and will spin up the container. And this container actually, this container will appear inside the domain and will be accessible to all computers in the domain. So we can see the container is running. I have started sometime before, and we can access another computer that will help us. We will demonstrate how we can access from different, totally different computer to this container. You can see I'm on a specific terminal server. I have a folder I have created here. This folder has been exported from my container. When I started this container, I'm using another scripts inside the container that actually creates a row-tailored client folder and export it to some shared folder. So users can grab this folder and take the folder and execute directly NAV without any installation. So you can see I can access this this database. This is the first step. I don't have NAV 2018 installed here on this machine. I'm accessing SQL 2, SQL 16, which is the instance. You can see server instance running on here. And if I run any object from here, I should be able to open also row-tailored client from NAV. I can also enter from this machine or from whatever machine on the domain. I should be able to access a web client. So let's try it. Okay, so you can see I actually can access NAV containers from any place, from my Windows credentials. So I can practically work with NAV in the same way I was working right before Docker. Like NAV is running on the standard NST VM machine. So this is the demo we wanted to show you about GMSA. GMSA actually requires some initial configurations. These configurations I'm going to describe on my GitHub repository to help you start using GMSA exactly combined with NAV containers.
Right, so really the important part there is that you've seen Jakub didn't have to enter any credentials and just used the Windows authentication and did a single sign-on to C-side, to the Windows client, and to the web client as well. So you really get the user and password and authentication handling of the Active Directory. Okay, as we're already quite close on the time, I think I'll continue on the presentation. If I can see the button to click, yeah. Now you should see my screen again. What we also wanted to show you, and I go through that quickly as we only have 10 minutes, is how can you customize the image? Because as we've just now seen, we were using a lot of scripts around authentication and database handling, but we didn't change NAV itself. What I'm showing you now is something that's working in the repository on GitHub, where Freddy has accepted those changes and merged it. And that's something I also want to mention. The work around that image really is very open. You can go to that GitHub repository and see how I requested that change, and we had a discussion around that and how we changed that, and it ended up like it is now. So that really is a place where you can also give your feedback, a lot of issues around how to work with that and how we can improve it, and that really works in a very open way, and that really, yeah, helps us as partners to get the product or get those enough images as we want them. And I would encourage you, if you're looking into that direction, to also share your thoughts and your needs there, because the image from my point of view is getting better and better. So two of the latest things that we have there is you can, when starting the container, download a zip file and put it anywhere in the container. So in that example that we have here, I'm adding a parameter that's called folders, and I'm telling it to put something into the C run my folder, and that is download a zip file and use the subfolder scripts inside that zip file and put it in C run my. And also I want to put something into the add-ins folder because I have some custom developed DLL, and I'm again downloading the same zip file and using the subfolder add-ins. And the other thing that we can do is we can change any parameter there is for the NAV server instance, for the web client, or for the Windows click once configuration. In that example, I would enable debugging, and I would disable report PDF font embedding inside of the NAV server. But how does that look in real life? I have an example here as well. What I'm going to do is I'm going to do a Docker run, accept the end user license agreement. I'm disabling SSL, so we won't see the certificate warnings that we've seen before. And then I tell it I want to change the web client setting so that the product name is new system, which is our product name at Axios Informa. Then I want to change a couple of NAV settings by disabling the NAV data export and by disabling the Word export for the reports. And then I want to download a file from here, and I want to use the subfolder custom images, and I want to put that into inetpub www root http so I can download it later. And the second thing I'm going to do is I'm using the same zip file, but using the subfolder custom add-ins, and put that one into the add-ins folder of the service using a subfolder Informa there. And then I'm using a 2013 RTM mission. The command that I'm actually going to use looks a tiny bit different because, as I said, that is available in the GitHub repository, but not yet in the official images. But as soon as those images are updated, you can do it like this. And now just a quick glimpse, because we're kind of running out of time, is there's a graphical environment where you can manage your containers. That one is called Portainer, and it's actually a container itself. And what you can see here is my custom NAV image. I can directly access the log file. And what you can see here is that it has already downloaded that zip file and extracted it and moved it to the folder where I wanted it to. And it also moved, downloaded it again and moved the custom add-in subfolder to here. So if you check what that zip file looks like, we have a zip file with those two subfolders, the add-ins where we have an Informa subfolder, and the images where it's just one JPEG in there. So if we again use Portainer to access the console, you can do the same from a PowerShell script, but I wanted to show you how powerful Portainer is as well. I'm looking inside of the add-ins folder. Now we should have an Informa subfolder, and you can see that it's created right now. So it really was copied in there. And if I look inside of that subfolder, you can see there are a couple of DLLs that I've put in. And then if I switch back to the log, it should hopefully have started. Yeah. And if I copy that URL and I copy the password and give it a second to load. Okay, we're going to start it. You can see here that the product name already is new system. So our first setting has worked. The web client change actually made the product name new system. We'll see that in a second in the role center as well. You can see here it's also a new system. And just to show you one of the changes that we also made using a report. And if I do send to, then the usual Microsoft Excel, Microsoft Word document export is missing because we've disabled that. I could show you that the data export also is disabled, but yeah, I think you get the point. Okay, with that, you should have seen how we can change any setting inside of a container and how we can download additional files. And the last topic will be how we can customize images and then actually store those changes. Because right now you've seen I can run that image and make changes on the fly. Sorry, but I might also want to do that and persist those changes, and you can that do through either Docker build or Docker commit. And with that, I'll switch it over to Jakub for the last 5 minutes. And sorry for running late.
Okay, so the last demo will be about building your custom images. I personally think that this is not necessary, and moreover, it can complicate you your life sometimes. Because if Microsoft publishes new images, you will need to rebuild the images to include the changes provided by Microsoft. So maybe you probably need some specific reason to use your custom images. I can imagine it will be useful for some big companies with many people working with NAV on Docker. And in this situation, you, for example, need to deploy some specific customization to many people, and you don't want to use the standard overrides that actually works perfectly with standard files. Just like in the previous example, you can download some template you should be using as an employee, and you can override the standard mechanism. So practically in the same way, you can build your own image. You can specify something called Dockerfile, and of course, you need to do it for every version of NAV you want to use. So this is the problem I was talking about. You need to rebuild images provided by Microsoft to add your content, your own content, and then you can use your images without any dependency. How to build those images? It's pretty simple. If you have a Docker file, in my Docker file, I'm using NAV 2018 RTM, and I will copy the content in the folder run, and then I will copy inside the container the folder called content from my host system, and I will copy it into run custom. So just be aware here, inside the folder run, I have subfolder mic, which is practically emulating the standard extension behavior. If you include something directly in the run folder, you will override completely the standard behavior. So this is also possible. We use it for debugging purposes, or if we need to fix something temporarily in the images that should be fixed on by Microsoft. So we temporarily use images like this. So how to start the build process? It's pretty easy. You can just run Docker build. You specify the target image name, and you will run this script. So I will do it. It's a really fast process because we are just adding a new layer into the existing container, and practically that's it. I can do next additional steps. I can export my port I need to use, etc. So I can do a lot of things. Then I have another option. I have the option tag the image. This means I will add my specific tag, and when I'm adding tag, I can put the prefix. The same prefix is using Microsoft. You know, they are using Microsoft, and in my case, I'm using my private registry. So the prefix actually can point to your private registry, and you can push your images in the final step into your own registry, and all your colleagues can download these images instead of using the Microsoft images. So the last step is the pushing. Actually, I don't have any private repository here called like this, so I won't push my image. I will show you just in the last step how I can run my image previously built. I will run this one, which reference to to the my one. So I will need to tag it. It has been tagged already, so I can run this docker run command, and you can see I'm referencing my own image. So in this case, if it doesn't exist, Docker won't run, and you can see it's starting already. So I have my image, my custom image called like this with this tag parameter, and I have everything included. Practically, I don't have any custom code in this folder. You can see there is nothing like my custom code here. So sorry. It's
Okay, Jakub,
Yep.
we need to stop you right now and show some housekeeping. Let's.
Okay, I'm stopping the sharing.
Okay. And then back to Tobias. If you have your screen with your links, and some people were asking if you would make your slides available. If you could do that on your blog, that'd be great.
Yeah, I'll share those. So just to maybe add on Jakub's presentation, that would be the way where you can how you can make those changes that I've shown before, bake them into your image, and just people can do a Docker run, and the changes will be there. No need for those additional parameters. So sorry for running late. You can see the links here to Jakub's GitHub repository and then to my blog, and we will share the presentation there. And I know Jakub is working on a couple of examples that we showed here today as well. So you can reference those in his GitHub repository as well.
Okay. And then for more information here, let's see, make presenter and show my screen. We had a couple of housekeeping rules that I really quickly glazed over. Is all the webinars are recorded. You can find them on YouTube, user Mark Brummel DS. New webinars can be found on the NAV Skills website. And well, please use the question window. Upcoming webinars is we're going to have Luke giving a testability framework on the 16th of January. On the 25th of January, Mark is going to be Prepare Your Architecture for NAV 2018. And on the 31st, Dave Studebaker with an intro to C-side programming. And that's everything. So thank you all for coming.
Thanks a lot for joining.
Thank you all. Have a great day.